Hello, this is John Hart, and we'll be going over comparing three or more variables here. We might think ANOVA right off the bat, but it would not make sense to use ANOVA when it compares means. For example, comparing resting heart rate to my weight. We can see that weight is going to be a larger number for the average. We can highlight that and get a quick look and look down here. Average 131 and resting heart rate. That average is 44.9. It does not make sense to compare the two for their averages or differences. We know there's a difference looking across 44 versus 134, 43 versus 132. But we can still compare the variables, just not their difference. We can compare whether there's a correlation between the two. So let's check that by inserting a graph. First, we'll highlight the data of one of the variables and press Control, and then come over here, let up on Control, and highlight the second variable. The chart will look at two variables at a time. Typically, we can make it complicated, and there's other ways to put more variables in, but usually there's just two. So we'll do a scatter plot, and let's make that a little bigger. And my heart rate is not zero. We can see that this is 0 and this is weight. And we can see my heart rate was never 0. We hope not. So let's adjust this down to say something more reasonable so we can see this a little better. Spread these dots out a little more. So let's say 35. Does that sound okay? Right click, format axis, and then 35. Okay, and there's really not a relationship. If there was, we would see tighter dots, and they'd either be going northeast or southeast. And here they're all spread out. And we could substantiate the correlation by doing a correlation test, Pearson. And I'm guessing we're going to get 0.2 or less. 0.5 would be a medium strength. We're going to get 0.2 or 0.15, I'm guessing. And it's weaker than that. 0.08 minus 0.08. Essentially zero correlation. Usually a coefficient has 3 decimal places. So negligible correlation between heart rate and weight. These two variables in the literature and research tend to have an inverse correlation. So let's check that. First, let's do a scatter plot. We'll get rid of that one. Between resting heart rate and heart rate variability. Insert, we'll do a scatter plot again. And kind of hard to tell which is which because they both go to 60. But we can come over here if we want to put labels. Once we figure it out, we see that the lowest value is about 39. And we could do a minimum, smallest, and find out which has the smallest, which has the 39. And it looks like resting heart rate. We can drag that over. The smallest for heart rate variability is 20. So this 39 is right here, and so that's resting heart rate. And before I forget, let's double click there and we get this up here. And let's try and find a template that where we can type in the x-axis title. Looks like that one will work. So this is resting heart rate, and this is heart rate variability. We can get rid of that. We can change the title. And we can change this to 35 again. Kind of spread that out so we can see it better. Looks like it's kind of going southeast. I mentioned the inverse correlation that literature tends to report, but let's do a correlation. It's going to be weak, but stronger than the 0.08, I'm guessing. So array 1. And array 2. And yeah, we have inverse correlation, and it's moderate strength, almost moderate strength. 0.4 technically is usually considered moderate strength, so it's pretty close to that. Inverse. And we could do a correlation between the variable with the largest numbers, and maybe we'll have a fifth variable down the line that's ranges from 0 to say 0.1, with all sorts of numbers in between, like 0.01, 0.02, 0.05, 0.021, very small numbers compared to weight. We could do a correlation there too. So it doesn't matter how small or large the difference is. It does matter if we're doing t-test. T-test, we have to compare apples to apples. Weight in one person versus weight in another, and those numbers may be quite different, but it makes sense. We're comparing apples to apples. And that concludes this presentation. Thank you for watching.